multiply these fractions together. I recommend changing them to improper fractions first. 1 times 100 is 100, plus 2 is 102, times 3 over 1. 102 times 3 would be 306. 100 times 1 is 100. And again, don't worry about reducing, just finish the multiplication. This is a digital lesson, so if you do not have access to the digital lesson, just go ahead and follow along and take notes in your composition book. It says, change the rectangle. How does the rectangle change? We can adjust the width and the length. It says, how does it stay the same? So the length and the width change. But if you look at the inside remains 24 square inches. That's the area, the inside. Make 2 different rectangles. Write the multiplication sentence for the area of each rectangle. So I'm going to start the first one. The area is 10 times 2.4, which came out to 24, not 34. If we adjust, I also have a rectangle that is 3 by 8, and that comes out to 24 as well. How are the factors in the first multiplication sentence related to the factors in the second multiplication sentence? In the first rectangle, the width was larger, but when we made the length 8, the width had to decrease. So as the width decreased, the length increased. You can also see, maybe not in this example specifically, because these decimals are a little harder to work with, but let's look at a third one. For example, if we used 6 and 4, well, this is 3/4 of 4, and if we went the other way, we have, let's see, 3/4 for the first one, but then 8/6, which reduces to 4 and 3. So it's the reciprocal or the flipped over version. So one is 3/4 the size, and the other is 4/3 the size. What do you notice and wonder about the rectangle as the length changes? So here I have a 4 by 6. Here I have a 0.4 by 6 and a 0.04 by 6. Notice how the area changes as we increase or decrease the length. I noticed that the 24, the area changed to 2.4 and 0.24, which shifts the decimal to a new place value, but it didn't change the digits. A 2 and a 4 were still there, but it changed the place value of those digits. I wonder what would happen if we changed the width instead. What is the area of the rectangle that measures 7/10 units by 3/10 units? Why? So here I have one hole, and this would be 1 as well. It's 10 tall. So each of these boxes represents a tenth. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 of them are double shaded or double covered. And this is a 10 by 10, so there's 100 boxes total. So it is 21 out of 100 boxes. Well, 7 times 3 is 21, and 10 times 10 is 100. We have 21 boxes are double shaded out of 100 boxes total. Use a grid to create a rectangle that represents the area of 0.42 square units. So enter a multiplication sentence that represents the area of a rectangle. Explain. So we need 42 boxes to be double shaded. So if I go like this, that's going to give me 20. There would be 30, 40, but if I do another 10, that's going to give me 50. So I can't get to 42 that way. Let's see if I go this way. I would have 9 in each row, 9, 18, 27, 36, 45. Now I have 8 in each row, 8, 16, 24, 32, 40, 48. Now I would have 7 in each row, 7, 14, 21, 28, 35, 42, 49. So I need to bump this down by 7. Let's see here. These are now 6s. 6, 12, 18, 24, 30, 36, 42. So this would represent 1, 2, 3, 4, 5, 6, 7 out of 10 going across in blue. And then going horizontally, I have 1, 2, 3, 4, 5, 6 rows shaded out of 10. And that would equal, well, 7 times 6 is 42, and 10 times 10 is 100. Use the grid to make your own rectangle. So you can design any rectangle you'd like. I'm going to do a 5 by 5. Enter a multiplication sentence with decimals that represent the area of your rectangle. Did the last one say I need to use decimals? No. Okay, so we're safe there. This one specifically asks for decimals. If I have 1, 2, 3, 4, 5 out of 10, that would be the same as 5/10 and 5/10, which is 5, 10, 15, 20, 25 out of 100. Well, 25 hundredths would be written as 0.25. use 4/10 times 8/10 equals 32 hundredths to help you find 4/10 times 8 hundredths. Okay, so we need 4 across in one direction and 8 the other direction. 2, 3, 4, 5, 6, 7, 8. That is 8, 16, 24, 32. So that would be 32 hundredths for the first multiplication sentence. But if I had 4/10 times 8 hundredths, well, 4 times 8 is 32, and 10 times 100 would be 1,000. 32 hundredths is written as 0.32, but 32 thousandths we need 3 decimal places, so that is 0.032. And explain how it helped you. The numerator would still be 32, but instead of using hundredths, this would be thousandths. The place value chart shows two factors with a product of 1,288. Change each factor to answer the questions. So I have 23 times 56 is 1,288. If I change the first factor to be 230 instead, I would need to adjust this one to be smaller to keep it the same. So that would reduce it from 56 down to 5.6, and I remain at 1,288. What are two other factors with the product? We have 230 times 5.6. What are other possible factors with a product of 1,288? Let's try and make it smaller than 23. Well, to make it back to 1,288, I need to adjust 56 back up to 560. So I have 2.3 times 560. So I'm adjusting those place values to maintain the same product of 1,288. Find a pair of factors with a product that is less than one of the factors. So currently I have factors 23 and 56, but the product is bigger than both of those factors. So I need to find a combination of two numbers where the product or the answer is smaller than one of these factors. So let's see, if I change it to 2.3, 128 is still bigger than 2.3 and 56. If I change it to 5.6, 2.3 and 5.6, those are both still smaller than 12.88. Here, I have 2.3 and 0.56. It says find a pair of factors with a product, so an answer that is less than one of the factors. Well, the answer 1.288 is smaller than 2.3. So we've got 2.3 times 0.56. Is that the only pair of factors with a product that is less than one of the factors? Try another pair of factors. Okay, let's see. What if we swapped it? Instead of 0.56, I have 5.6 and 0.23. 1.288 is still smaller than 5.6, so that would work as well. What do you notice and wonder about the place values of the three numbers? Right now, I only have zeros in the tenths, hundredths, thousandths, and so on. So I don't have any numbers besides zero in those place values down here. But if I adjust to make it 2.3, now I have one number down here in the tenths, which gives me one decimal place in the answer. If I adjust to 2 digits in the tenths, then I end up with 2 decimal places in my answer, or 2 digits in the decimals in my answer. So I notice when there is one decimal place in the products or in the factors, the product has one decimal place. When there are two decimal places in the factors, the product has two decimal places as well. And it doesn't matter if it's one in the first factor and one in the second factor, or if I put both of them in one factor, so two decimal places in the first factor, none from the second, but I still end up with 2 in the answer. So again, checking this out, if I have 1 in the factor, 2 in the factor, 3 in the factors, because I have 1, 2, 3, then I end up with 1, 2, 3. If I have 1, 2, 3, 4, then I end up with 1, 2, 3, 4 digits in the answer as well. It says, insert decimal points into each number. Enter the new multiplication sentence. Does the new product use the same digits? Explain how you know. So right now I have 1, 2, 3, 4, 5 decimal places in the factors, but I only have 4 in the answer, so this doesn't quite line up. If I move it here, I have 3 decimal places in the answer, so I only get 3 in the factors. So 1, 2, I've got to move this so that I have 1 here. 1, 2, 3. And then I have 1, 2, 3 in the product. Does it use the same digits? Yes, it still uses the same digits. By changing the location of the decimal, we just shift those digits over to change the place values. But the digits remain the same. So if I wanted to change it, I could put 1, 2 decimal spots in my question and 1, 2 in the answer. The digits remain the same. The only thing that changes is those place values. Order from least to greatest. Okay, so they're all multiplied by 16. So I just need to look at which fraction is least and which fraction is the greatest. They're all over 1,000, so we need to look at the numerators. 500 is the smallest. The next smallest would be 505. then 510, and finally 520. Explain how you ordered the expressions. I saw all of them were multiplied by 16, so I just looked at the fraction, or the fraction factor. All of the fractions had the same denominator, so I was able to compare the tops, or the numerators. Again, these are all multiplied by 16, so let's look at the factors. I see I have 0.5, which we could rewrite with extra zeros behind it. So this would be 0.500. This one is 0.505. This one would be 520 and 510. So if we were to put them in order from least to greatest, 500 is smaller, then 505 would come next, 510, and the greatest would be 520. So let's rearrange these. The first one, or the least, is going to be this guy. Then we have this one up next. 510 would come after that, and 520 is the greatest. So again, they all were multiplied by 16. So I looked at the decimal factor. I rewrote them as decimals in the thousandths place, and then I compared them. So this one isn't multiplied by 16. All of these have a 5 and then some form of 16, but the amount of decimals in each one is different. So here I would have a value that has 4 decimal places. So these would end up in the 10 thousandths. This one would have 1 decimal place. So it would end up with the ones and the tenths. Here this one has 1, 2, 3, 4 as well, but it's multiplied by tens, or 5 tens, so that one's going to be bigger than the one that has, actually it might be the same. Let's look at it. 16 times 5 is 80. 5 times 3 is, 5 times 6 is 30. 5 times 1 is 5, plus 1 more makes 80. So 5 times 16 is 80. Now, this is going to be 80 with 4 decimal spots. So 1, 2, 3, 4. So this is 0.0080, or just 0.008. This one is going to be 80, but we have 1 decimal spot. So this is actually 8.0. This one would be, it's not 16 times 5, it's actually 16 times 50. So that is 800 with 1, 2, 3, 4. 1, 2, 3, 4. So this is 0.08. And then this guy, 16 times 5 is 80, but it has 2 decimal spots. So 1, 2. This is So the greatest is going to be 8, the whole number. The next largest is going to be in the 10ths place, which is this one here. Then we have the one that's in the 100ths place. And the smallest is going to be the one that's in the 1000ths place. So explain how you ordered these expressions. We multiplied 16 by 5, and in one case 16 by 50. Then we counted the decimal places in the factors and put the same amount in the product. Then we were able to compare them. Make sure your warm-up is finished and your workbook is filled in for lesson 14.